Now let's take a look at the substitution rule and how I'm going to apply this for definite integrals. There's actually two different major approaches to this. Now, the first approach would be to apply a use substitution when I'm working with definite integrals, and then that would require in the use substitution is converting back to values of the original function. So if I had a function of x and I did a use substitution, I'd end up with a function of u, and then of course I need to switch back. So that's what I've been doing these last several examples. And then once I switch back, then I'll go ahead and integrate these bounds. In this case, in this example, from 0 to 1. Or I could change the bounds. There's two different ways of approaching this. That second approach is simply changing the bounds. I would no longer be integrating from 0 to 1. I'd be integrating with different bounds. So let's walk through this, and I'm going to use both procedures for it. So first I'm going to use procedure number 1, which is exactly what we've been doing. Now, looking at this, I'm going to let u equal x cubed plus 2x. That means that du equals 3x squared plus 2 dx. That's exactly what I have right there. So now I'm going to integrate u squared du. Now notice I have these bounds 0 to 1, but I just changed variables in u, so these bounds no longer belong there because it's not 0 to 1. It would actually be something different. But I'm going to continue with my u substitution, go back to x, then think about these bounds. So this integral is just going to be u cubed over 3. And this time I'm not going to do plus c, because this is really a definite integral. Here's my bounds. But u was x cubed plus 2x. So what I really have is x cubed plus 2x cubed over 3 evaluated from 0 to 1. Well, that 1 I'll get, what will I get there? I have 3, so this would be 3 cubed over 3 minus, this evaluated at 0 is just going to be 0. So this will end up being 3 cubed over 3, that is 3 squared. So this whole thing is going to be simply equal to 9. Now, the second process would be to do exactly like I did, only I'm going to make one modification. I'm still going to use a u substitution. I'm still going to end up right here. I'm still going to end up with u cubed over 3, but the difference is I'm going to look at u as a function of x. So I'm going to say u of x equals x cubed plus 2x. Now, u of 0 equals 0. So that means my lower bound, where I had a 0 here, is still going to be 0. My upper bound, where I had a 1, is going to be u of 1. U of 1 is going to be 3. So I'm going to integrate from 0 to 3. There's my new bounds. So now, when I integrate from 0 to 3 of u squared du, I get u cubed over 3 evaluated from 0 to 3, which brings me right back to where I was. This is 3 cubed over 3, which is just 9. So I get the exact same solutions. Here, I change the bounds, and on the original one, I changed back to x and then used the original bounds.